Hello everybody, this is Andy Pills and it is our third day in Unit 8 on climate, and in today's video I'll be talking about a couple additional features or factors that are going to affect local climate. So in previous videos we talked about latitude and how locations that are close to the Earth's equator are going to have warmer temperatures, and as you move closer to the poles we're going to see cooler temperatures. We also looked at how moisture affects the different types of plants and vegetation and wildlife we'll see in those climate zones. Today we'll take a look at a few more factors that will influence climate. So we took a look at this region's question a while ago, but just as a reminder, we are comparing climate in Reykjavik, Iceland with Yakutsk, Russia, and the line graph is going to show us temperature, whereas the bar graph shows us precipitation. So if we look at air temperature in Reykjavik, you'll see that it fluctuates between 0 degrees Celsius and about 12 degrees Celsius. So not that much of a big temperature difference between the warmest and coolest months. But if we look here at Yakutsk, we'll see that the air temperature in the cooler months is below -40 degrees Celsius. And in the warmer summer months, it reaches a nice warm tropical temperature of 20 degrees Celsius. That is not tropical. Okay, now that we've looked at some of this climate data, let's switch it over to Google Earth and see why this is occurring. If we look at Reykjavik, Iceland, we're going to see that this city is right on the water in Iceland, and it's really going to be influenced by the nearby ocean. So water has a very high specific heat, which means it takes a lot of energy to change the temperature of the water, which is why we see a relatively small range between the lowest and highest temperatures in Reykjavik. If we look at Irkutsk in Russia, it's much further from the ocean. Land has a lower specific heat, which means we're going to see a greater variation because of the sun. So when the sun is shining during these summer months, it will get a little warm comparatively for Irkutsk. And during the winter months when the sun is lower and they're not getting that direct sunlight, since the specific heat of the land is so low, it's going to lose all of the heat, and we're going to have a greater difference between the summer months and the winter months. We also see that climate difference in the eastern United States. So in New York, we're on the eastern coast of the United States, and our climate is really influenced by the nearby Atlantic Ocean, as well as the Gulf Stream current coming up from the Gulf of Mexico. If we were to look at cities that are more inland and further away from these oceans, we're also going to see greater fluctuations between the winter months and the summer months. Another factor that's going to affect an area's climate is the topography. So we've seen rain shadows in our previous unit on weather. We saw how a mountain may make warm, moist air increase in altitude, and as that air rises, it's going to cool, reach its dew point, condense, and cause precipitation. So one of the best examples of a rain shadow is the Atacama Desert that's on the west coast of South America to the west of the Andes Mountains. Again, let's take a look at Google Earth and see what this looks like, a rain shadow of the Andes Mountains. So we see a lot of warm, moist air coming from east to west in South America. As the air moves across the continent, it's going to run into the mountain range that we see right along here. As the Nazca plate here is converging with the South America plate, it's going to create a mountain range here, which means that these areas to the east of the Andes Mountains, they're going to receive a lot of precipitation. But as the air moves over the mountain and it begins to drop again, it's going to warm up. That air, as it warms, it's going to expand, and it's not going to create that cooling that we'll need to create a cloud and create precipitation. So any area that's on the opposite side of that mountain is going to be in the rain shadow, and they'll have very little precipitation. One last thing that we're going to be discussing today is the relationship between Earth's tilted axis and the climate zones that we have on Earth. So back in our insolation unit, we learned that the two reasons for seasonal differences on Earth are Earth's revolution around the sun and the 23.5 degree axial tilt of the axis of rotation. So I thought it would be appropriate to go back to our CPUP season simulator and take a look at the effect that the axial tilt has on temperatures. So we can take a look at Chicago, Illinois, which has a similar latitude to us here in New York. We'll see that during January months, the temperature is cool. The average temperature is about 21 degrees Fahrenheit, where throughout the year it's going to warm up. And then when we get to our summer months, our solstice, and then July when it's warm, July and August, we see 73 degrees Fahrenheit average temperature. And then we'll go back to January. If there was no tilt, let's take a look what would happen. First off, again, 23.5 degrees, we have a difference of 21 degrees and 73 degrees. So we have about a range of 52 degrees Fahrenheit. If there was no tilt, then the angle of incidence would be the same no matter what the month is. As the Earth rotates, no matter where Chicago is, as it rotates, it's going to get that same angle of insolation. So because of that, if the tilt is 0, we're going to see the same temperatures throughout the year. So if we had a higher tilt, then we're going to have warmer temperatures in the summertime and cooler temperatures in the wintertime. If that tilt was more, we would just see more of that effect. We would see, if it was tilted more towards the sun, then we would get an even warmer summer. And during the wintertime, it would be tilted even further away, which means that it would be a cooler winter. So that's also how the tilt affects the different climates that we see on Earth. So just like a tilted axis is going to give us seasonal changes, if there was no tilted axis, we actually wouldn't see any seasonal changes. So over the course of the year, we see these temperatures remaining constant because no matter the latitude, we see the same angle of insolation over the course of one rotation. But let's take a look at what happens to our climate zones. So in Anchorage, Alaska, over the course of the year, it's going to remain 26 degrees Fahrenheit, no matter where you go, or -3 degrees Celsius. So that means that those warmer climates are going to be stretching more towards the poles, and those polar climates that we usually get, so those winter months when it gets very cold, we won't be having those as much. So those polar climate zones would either shrink or they might even disappear. If the axial tilt was increased, so instead of 23.5 degrees, it was maybe 35 degrees or 50 degrees, well, then we would see even greater variations and changes, which means that our temperate climate zone would increase. That means that more areas on Earth would be experiencing 4 seasons and big changes throughout the winter and the summer months.